Greetings all. Welcome to my pool deck in sunny central Florida, where today it's cold and rainy. But the weather guessers are saying that tonight it's going to clear up and we're going to have some clear skies. And if that happens, then we're going to go after the Crescent Nebula. Now the Crescent Nebula is an emission nebula out in the constellation of Cygnus, about 5,000 light years from Earth. And the way this nebula happened, there's a star, it's called a Wolf-Rayet star. It's Wolf-Rayet 136 if you're interested. And this giant star has shed all of its outer layers. It's finished fusing hydrogen and it's began to fuse helium and other heavier elements, giving it a fairly unique signature. This star is burning really bright, and the stellar winds are shaping the gas that it blew off, shaping the atmosphere that this star has blown off. And the high temperatures and the extreme radiation are ionizing this gas, turning it into an emission nebula. Now the Wolf-Rayet 136 star causing the Crescent Nebula is massive enough that one day, and it is nearing the end of its life, but one day it's going to collapse and then explode into a giant supernova. So anyhow, that's what's causing the Crescent Nebula, and we're going to take a picture of it tonight if it clears up. Now tonight I'm going to be using my new Edge HD11 telescope, and let me show you the rest of the equipment we're going to be using and a few things about this telescope. Tonight, the Crescent Nebula. Alright, let me show you some things about this scope. Well, there it is, setting up on the iOptron CEM60. And look at my counterweights down here. I had to go and get some more counterweights to put enough weight on there to balance it. And I got to tell you, it is not easy to balance this scope. In the declination axis, you see I had to put these weights on here. I found this thing that just hooks on by a dovetail to the bottom of the bar here, and it only came with one weight, but I bought another weight for it, and that still wasn't enough to get enough weight on it to balance it in the declination axis. So I took a counterweight from my small mount, my Skyguider Pro, and I just kind of sandwiched it in between there, and then that gave me enough counterweight to balance in the declination axis. But it's not easy, I'll tell you that. Now, one thing I'll show you, you see I got my 4 dew heaters up there, which I need to have, but let me show you what else I've got on here. You see that right there? It's a dew heater ring. It just replaces the ring that holds on the corrector plate, and it puts heat right on the glass. So between my standard dew heaters and this new dew heater ring, I'm hoping that that's going to be enough to keep this big old telescope clear of dew, but time will tell. Now let me show you the rest of it. Look at this big old image train back here. It's 2-inch equipment rather than the 1 1/4 that I have on my other scopes. But look at that big old focal reducer right there. Of course, this scope doesn't need a fill flattener because the Edge Optics takes care of that. But this right here is a 0.7 focal reducer, and that thing is heavy. I forgot how much it is, but it's a handful. I've got a 2-inch Celestron off-axis guider here. I'm using my Starlight Express Lodestar X2 as the guide camera. I've got a automatic camera rotator on here now. I haven't been able to get it to work yet. I'm still working on that, but it's there, and soon I'll get it to working so I don't have to do manual rotations. Right behind that I got this is a 2-inch filter well. It's a ZWO 2-inch 7-position filter well, so I can fit all my LRGB in there, my broadband, and I can fit HA03 and S2 in there. And then finally the ASI 1600mm Pro. But that's the image train, and I got several spacers and adapters and stuff in there to make it all hook together and get to the right spacing. That's what we're using. The iOptron CEM60 carrying the big old Celestron Edge HD11 with the 2-inch image train. Alright, here we sit, getting ready to go on the Crescent Nebula. Let me show you where we are. Right now, I just set the mount up, I balanced it, hooked everything up, and we're pointed up towards the North Star right here. The North Star hasn't popped out yet. I'm waiting for it to get dark enough for it to pop out. Then I'll go ahead and do my polar alignment. Everything else is ready to go though. From there, I'm going to go over to this bright star called Vega right here. And on Vega, we're going to do our focus. And then from Vega, I'm going to come back around here to the double cluster. Sits right over here. And this is where I'm going to do my auto guide calibration. And then we're going to go back up here to the Crescent Nebula. Now you might be wondering, why am I going all over the map here? Well, I'm going to Vega just because it's a bright star. It's up pretty high, and it'll be easy to do my focus there on Vega. Now the reason I'm going back to the double cluster is because for some reason with this telescope sitting on the mount, whenever I go to the double cluster to do my auto guide calibration, I get a much better calibration than I do anywhere else in the sky. I normally get a better calibration closer to the equator, the celestial equator, but not in this case. And I have two ideas on why that might be. First of all, if you go here and look at the double cluster, you'll see there's a whole bunch of stars there. So it may simply be that there's a bunch of stars for the auto guider to use to do a calibration. That's a possibility. The other possibility, and this is the one I suspect is more likely, this is a heavy scope. Once I put my image train on there and everything, it's heavy. I think it's right at the limits of this mount. So when the scope is laid down on its side, you got the big old telescope and the image train sticking out on one side, and you got those big old counterweights on the other side. Even though it's balanced, that's a lot of inertia for those gears to move, and it can handle it. Okay, but I think when the mount is standing straight up, so now all of the weight goes right down, the center of gravity goes right down through the center of the mount, it's a whole lot easier for the mount to move the scope around, much easier. So when the auto guider is trying to make its calibration adjustments, it's a lot easier for it to nudge it when the scope is standing straight up and down and all the weight's going right down through the center of the mount. That's my theory. I believe that's why I get a much better calibration on the double cluster, simply because the mount is standing straight up and down when I point at it. If that's true, then I should be able to point at any target where the mount's straight up and down and get an equally good calibration. I may check that out one night, but for night I'm just going to go to the double cluster and calibrate because I know it's going to be good. After that, then we'll go back up here to the Crescent Nebula. Let me show you what that looks like. Zoom in on the Crescent Nebula here. There it is right there. I put a marker here that I want to use this marker as the center of my frame, and you can see it frames it up nicely there. See this rectangle here? This is how we're going to be framed up. And if you look over here, you see that I do have the right stuff in there. I've got the Edge HD11 as a telescope. I've got my 0.7 focal reducer in there, and I've got the ASI 1600mm Pro dialed up. In this little rectangle here, this supposedly is where the guide camera is going to be looking at. And in this instance, you can see there are no stars right here, because remember, it doesn't see the whole view that the main imaging telescope sees. it just picks off a little bit of light out the top of it, and that's why it just sees this little rectangle, because it just picks off some light on the edge of the light cone coming in. So it doesn't see all of this stuff in here, but I'm counting on the fact that there is going to be some stars in here, even though Stellarium doesn't show any. If for some odd reason there's not, then guess what? I'll just rotate the guide camera until I can find some stars. And this setup allows me to rotate the guide camera without rotating the rest of the image train. So I can keep the main camera in this orientation and just rotate my guide camera if I need to. I haven't had to do it yet. Anyhow, here's the Crescent Nebula, how we're going to frame up and how we're going to get going on it. Now, let me show you the imaging plan that I have built for the Crescent Nebula. Alright, here's my Crescent Nebula imaging plan. I built it earlier today in Neener while I was preparing for tonight's session. And let me tell you why I picked this. First of all, I'm going to do HOO palette. So I'm filming in hydrogen and oxygen. I think it is a good narrowband target. I don't think I'm going to get much sulfur, so I'm going to do an HOO composition on it. Now you might think it's odd that I'm starting with O3 normally, but I found that I always start with hydrogen and I get way more of that than I do with oxygen. So tonight I'm just going to start with the O3 filter. We'll get a bunch of O3s, then we'll get some HAs, and then we'll get some more O3s. Now notice I'm doing 10-minute exposures. Now this is not going to be enough to finish this image. If you see over here, I'm going to be shooting for 4 hours and 15 minutes. I want to get a minimum of 12 hours on this object, probably 15 to 18 hours is what I'm going to shoot for. So that means I'm going to have to go 4 or maybe even 5 nights on this object. So this is just night 1. So I'm not worried about the fact that my O3 and HA frames are not balanced. I'll have plenty of other nights to balance them on up. But if I start right at sunset and run for 4 hours, then the Crescent Nebula is going to set. And let me show you why I think that. Back it up here. I'm sitting in current time right now, and the Crescent Nebula is going to set over here in the northwest. And looking back to the northwest, I can no longer see it. It goes behind my trees at about 20 degrees above the horizon. So let me run this forward and take note. Watch the altitude right over here. So as soon as this altitude gets down to about 20 degrees, that's when it's going to go behind the trees and I can't see it anymore. So let's fast forward time and watch right here. We're looking for 20 degrees right here. Alright, so there's about 20 degrees right there, and you see down here, this happens at time midnight 30. So if I start shooting right at sunset, shoot for 4 hours and 15 minutes, it's going to be midnight 30. I'll probably actually finish up around midnight, but I always give myself a few minutes for focus issues, dithering in between frames, meridian flip, whatever the case may be. So that's the reason I selected that amount of frames. I think I'll start going at sunset and I'll finish right about the same time the Crescent Nebula sets. Now I'm not going to waste the rest of the night. I'll move on to another target after that, but that'll be a different video. For tonight, the Crescent Nebula. So here we go. And yonder it goes, headed over towards Vega, just like we told it to do. And I can tell you it is going in the right direction to point at Vega, so that's a good sign. So there, the telescope thinks that it's pointed at Vega, and I can tell you it looks like it is. So let's go find out, did it really get on top of Vega? Let me show you how I focus this scope. This knob right here and this knob are the mirror locks. It's what locks down the primary mirror so the mirror doesn't move while you're imaging. So I just loosen those just a little bit. You see they're loose here. So I'll be able to move the mirror now, and then come around here, and then here's the focus knob. So I'm going to go counterclockwise just a frog's hair. Right there. Now we're going to go take a look and see did I move it the right way or the wrong way. All right, you see right here, the telescope is standing almost straight up and down, perfectly in line with the pier. You see that, as opposed to being leaned over on the side. And I believe because it's straight up and down like that, aligned with the pier, it doesn't have a lot of inertia to overcome on the gears to make it move. So I think that's what's giving me the superior guiding and calibration, is that it's standing almost straight up. There's not as much inertia for it to move. Anyhow, that's what I think. Okay, yonder are the trees where the Crescent Nebula is going to go behind and set. It's going to go behind those trees right there, about 20 degrees high. Now, if we go up just a little bit, you see right there is the star Vega, which we did our focus on, and then swing just a little bit more around, and right there you see Cygnus, the swan. You see those 3 stars in a row. That's his wingspan. And then the bright star is Deneb. That's like right in the middle of his back. So if you go from Deneb, that star in his back, up his backbone to the center star in the wingspan, and then follow it out just a little bit more where his head would be, that is the Crescent Nebula. So the Crescent Nebula is right there. You line up the backbone, those 2 stars, go just a little bit further out, Crescent Nebula right there. Okay, here we go. And there it goes from the double cluster headed over towards the Crescent Nebula, just like we told it to do. So far so good. Alright, so I thought I'd show you one thing while we're waiting on that first exposure to come in. Look at the auto guiding down here. We're right at 0.77. So it's been running on the Crescent for a while. There it is, 0.77, 0.76, 0.75. So I'm happy with this. That system that I showed you works. Alright, here we go, about 8 seconds until our first HA image comes in on the Crescent Nebula. Let's watch it come in together. Our first 10-minute HA on the Crescent Nebula. There it is. There it is. How about that? How about that? I like this. I think it's got a lot of detail in there. And you see right here, this is the part of the outline on the Crescent that we could see just in that plate solid image, this part right here. Anyhow, there it is, the Crescent Nebula, framed up just like we wanted it to be. I like this. Now, you might notice here that there's a little bit of amp glow. That's what these things are. That happens with this ASI 1600 mm Pro. But you know what? I have some darks, dark calibration frames that will take that out. Take that amp glow out when I stack them. So anyhow, there it is. You know what? I said that wrong. Doggone it. This is a 03. I tricked myself. I normally do the HA first, so I was thinking this was going to be an HA, but it's not. This is an 03. Look at that. This is an 03 frame. I got to tell you, I'm even more surprised now. I wasn't expecting this much 03 signal. That's about what I was expecting from the hydrogen alpha. But look at that. Look at that. All that signal coming in through the oxygen filter. I got to tell you, I'm a little bit blown away by that. I'm highly encouraged by this. And now I can't wait to see the hydrogen filter. That's going to be even better. Anyhow, this is great. I was not sure that I was going to be able to handle this big old HD11 edge with all that focal length, 2,000 millimeters. But I tell you what, this is encouraging to me. I like what I'm seeing here, and I think the HA is going to be even better than this. So anyhow, I'm going to let it run. I'll probably come back and look at one or two more on the way in, and I'll certainly come back and we'll look at an HA image when it comes in. But until then, I'm going to let it run, and I like this. This is working out. This is working out good. This is going to be good. All right, let me show you all this pretty neat map I found here. It's a weather map. It's something called GOES satellite. Seems to be pretty good. Anyhow, here's Florida. Of course, this big blob here is Orlando. Lakeland sits down here, and then here's Tampa, right over here. Tampa, St. Petersburg, and so Orlando, Lakeland, Tampa, St. Pete. And then you see this dark blob right here. I sit dead in the middle of this dark spot right there. That's where I'm telescoping from. It's right in the middle of that darked out spot right there. This is the green swamp, but so that's where I sit telescoping tonight. You can see from the clouds up here, this is pretty clear all night. But anyhow, I thought this was a pretty neat shot that shows the city light pollution and stuff. And you see how I'm right out here in this darked out spot. And I can tell you that was not by accident. Alright, here we go, about 5 seconds for our first hydrogen image. Our first 10-minute hydrogen exposure on the Crescent Nebula. Here it comes. There it is. How about that? How about that? I'm pretty happy with that. It's a little brighter than the O3 was, like we thought it was going to be. There's really good detail in there. You see that detail along the edges, these ripples through here. I got to tell you, I'm pretty happy with this. So we got a good start on this night. We should get about 4.5 hours tonight. I told you I want to get about 15 to 18 hours, so I'm going to be going probably 3 more nights on this object. But this is a really good start. And we've looked at the 10-minute O3, we've looked at the 10-minute HA, and I tell you what, I'm just going to let it run, and unless anything weird or strange comes up, then I will see you at the end.